Now I'm going to show you a demo with Heather of the Leptonite app, and this is just to recap on the objectives. The Leptonite app has been developed to demonstrate to developers, to engineers, how what type of dCommerce applications can be built on top of Boson Protocol. To go to the Leptonite app, you have to go to leptonite.io. This is the homepage that I've got because I've already connected my wallet. But if you are a new user, you will see a number of onboarding screens which will explain what is Leptonite, what is Boson escrow code, and how it holds the deposit and deposit amounts and payment amounts. And then you can proceed to connecting your wallet. So in this example, I have already connected my wallet, and I'm on this homepage. As you can see, there's a number of items that have already been listed for sale in the live version of the app. So today we're going to show you a flow of the seller listing an item and the flow of a buyer buying an item. So I'm going to proceed with listing an item, and in order to list an item, we have a number of categories to select. These are predefined categories for the purposes of the reference app. So I'm going to go with with shoes. I'm going to list Boson Nike. I've got some Boson merch Nike for sale. So that takes me to the traditional sort of commerce flow when you enter the item details. So that will be Boson custom Nike trainers. Great condition, quality. Once I can decide on what type of condition it is. Is it new or used? So I'm going to go for used. On this page, I select the quantity. Of the moment, in the reference application, the maximum quantity is 10. So I'm going to go for 10. And then in these three fields, I choose the number of the cost of the item, so the payment that I expect the buyer to pay, the deposit that I'm going to lock into Boson escrow, and the buyer's deposit that needs to be paid in order to purchase the item. You could also choose Boson tokens as a deposit and a payment currency, but we're going to go with Ethereum. So my Nike trainers will cost 0.005 Ethereum. Deposit amount, I'm going to set at 0.001. At that point, I'm now selecting the voucher start and expiry date. So after expiry date, a voucher cannot be redeemed anymore, and the buyer needs to redeem the voucher before the expiry date. So let's assume I'll leave it till the end of August. And then I'm presented with the pickup location screen. While we're developing the Boson protocol, it currently only supports click and collect. So at the moment, you can only list an item that can be collected in person, at a location, at a shop, or face-to-face with someone else. In the future, we'll be working on developing delivery and full fulfillment as per our roadmap. Now I'm presented with an offer summary screen. So that allows that on this screen, the seller can review the offer just to make sure that the deposit amount are correct, that the start and end dates are correct, the address is correct, and they can click offer. And Heather is going to explain what's happening at this point.
Okay, when the user creates offer or clicks offer, you can see that MetaMask pops up, and that's because a smart contract is being called. Now, before the smart contract is called, as I mentioned earlier, we're actually creating a draft record in the back end. And this is so that we can do some updates to the front end before the Ethereum transaction finalizes. But at the point that the MetaMask window pops up, that has already happened. So the user can click on confirm. And then what happens is the Boson router request voucher or request create order, gets called in the Boson router smart contract. And again, there are 4 different versions of this function, because there are 4 different permutations that can be used for the payment and the deposit. You can have ETH if the payment and the deposit are ETH. You can have ETH token if the payment is ETH and the deposit is in a token, and you can have token ETH and token. So what happens when this function is called is an ERC 1155 multi-token is minted with the quantity that the seller specified. And that represents the voucher set. And also the seller's deposit is put into escrow in the cashier smart contract. And then the log order created event is emitted. And as I spoke about earlier, the event listener listens for that event. And when that event is caught, then the draft record in the backend is updated.
So what happened now, as you did see when Heather was explaining, the transaction was pending. At that point, the user would see that it's being confirmed then. And when complete, I would see a pop-up which would show the transaction has been confirmed and the voucher has been created. Sorry, the voucher has been created, the voucher set specifically. So at that point, as a seller, I can see in my in a number of vouchers that I have in my account that are 10 quantity. But none of them are active because nobody has actually purchased a voucher. And you can view those in this view, which is, as I mentioned before, you've got purchase, which is a list of your purchased items and a list of your offered items here. So now I'm going to switch my wallets and go to a different wallet address and pretend to be a buyer. One thing to keep in mind is that if you list your own items, you can't see them in the front end. So the sellers can't buy their own items. So you can only see my Nike trainers. So as a seller, I can't see my Nike trainers here, but as a buyer, I will be able to do so. Now I'll switch wallets to a new wallet, and I'll pretend to be a buyer. Again, all that flow is mobile responsive. Typically, a buyer would browse this on a mobile phone and actually redeem this in a physical using their mobile phone. As you can see, I can see the item that has just been listed. I can see the costs and the deposit amount. So I can view all the description and the information that has previously been created by the seller. I find it interesting, so I decide to buy and commit. And Heather will explain what's happening at this point.
Okay, again, when the buyer clicks the button, we create a draft record in the backend, and then you can see that MetaMask pops up because, again, a smart contract is being called. So when the user confirms, then the Boson router request voucher is called. And again, we have 4 different versions of the request voucher function because we have one for each permutation of Ethereum and token that people can use for the different payment and deposit permutations. So what happens when this function is called is that first, one of the ERC 1155 that was created for the voucher set is burned, and then an ERC 721 that represents the voucher is minted, and also the buyer's payment and the buyer's deposit are put into escrow in the cashier contract at this point. And again, there is an event emitted, and the event listener listens for this event, and when the event is caught, it again updates the draft record in the backend.
Thank you, Heather. So at that point, my transaction has been confirmed and commit has been triggered. As a buyer, this means that I have paid my deposit amount and I have paid the payment amount into the Boson escrow, which means I have some skin in the game. And from the game theory point of view, the buyer has entered the game. So he's committed to buy this item, and he's minted a Boson commitment NFT, and his wallet is attributed to his wallet. So what I can do now, in this view, in the purchase section of the app, you could see the different vouchers I've purchased in the past. The Nike trainers I've just purchased a commitment NFT for could be seen here, but there are different items with different statuses in the game tree that we have created at Boson Protocol. So as a user, then I can view the deposit amounts that have been locked, and I can see what's the status of the escrow. Let's pretend that I'm actually going physically in person to 10 Oxford Street in London and would like to redeem this item. So using my mobile phone, I would click redeem. This would produce a QR code, which then can be scanned by the seller to verify that this user is actually identify what voucher this user wants to redeem. And then I proceed to sign a redeem transaction. And Heather, could you explain what's happening in this stage?
Yes, again, there is a draft record created in the Leptonite backend, and then of course a smart contract is called. And again, the Boson router smart contract is called, and the function is called redeem. And what happens at this point is that we set the status of the voucher to redeemed. Now, we're not burning the ERC721 token. That token is never getting burned, but we also keep track of the voucher as a struct in a mapping. So at this point, we're just setting a status in a struct. And another important thing we're doing at this point is we're setting the complain start period to the current block timestamp. And that means that from that point on, the buyer has 7 days to complain. And then again, of course, we have an event that is emitted, which is listened for by the event listeners. When that event is caught, then again, we update the draft record in the backend.
Thank you. So, and that's important as well to note that at that stage, I'm trying to show you, at that stage, users would only redeem, send a redeem transaction if they have inspected the item. You would see, I would probably try those trainers on and see if they are the quality as described, whether they actually were used once or not. And then if I'm happy, I proceed with signing the redemption transaction. And as you can see, all the status of the current voucher is presented here on the top. And as a buyer, then I can go away and happily wear my trainers and run and do whatever I'd like. Or I can, after some time, because I've got a wait period of 2 weeks, as per the game theory, I can actually complain. So I'm going quickly to show, and being cautious of time, I've got 2 minutes left. So as a buyer, I may not be fully happy with the trainers, so I would like to complain, and I can send a complaint transaction when I'm back at home and when I think that the item isn't of the quality that it should be. As you know, it's important because things always go wrong in e-commerce. That's why we've got those arbitration systems and ways to return items. So at that point, what happens is a complaint transaction is sent. Complaint has been triggered. The status has been updated, and now I'm going to switch to the seller wallet again, just to show you what happens on the other end. If I'm a seller and I go to the Boson Nike trainers voucher set, I can see that someone has made a complaint. And then as per the game theory, what I can do, I can agree with that complaint and I can do cancel or fold, which will then change how much deposit I'm going to receive, because I've also paid some deposits as a seller. So I'm admitting my fault, which means I'm going to lose a portion of it or some of it as per the game tree. And by doing so, that's sending a cancel or fold transaction. Heather, is there anything interesting worth mentioning about the cancel or fold at this stage?
At this point, the cancel or fold, again, we're just setting a status on a struct in a mapping. We're not doing any kind of burning, and so basically we've set that the status that has been canceled or faulted.
Great, thank you. So at that point, we have gone through the full cycle where users have bought an item, complained, and the seller admitted the failure. Of course, the purpose of the Boson Protocol is to create the highest amount of the highest quality voucher redemptions, which is sellers list high quality items without any faults, and buyers buy those items that they committed to. But as you know, sometimes it happens, and we have to cater for those scenarios, and therefore Boson Protocol automates that arbitration, that exchange, and by this game tree developed by Boson Protocol.